X is a binomial distribution. N is 500, and P is 0.2. Now we're trying to find Px less than 50. This means that we have to add from 0 to 49. These are 50 terms to add and too many. Is there an easy way? Let's look at the probability graph of several binomial distributions with different n and p. We can see that under some circumstances, a binomial distribution will look like a normal distribution. Let's see how we can approximate a binomial distribution with a normal distribution. X is b, n, p. If np is greater than 5, and nq is greater than 5, then x can be approximated by a normal distribution with np as the mean, and npq as the variance. This is because a binomial distribution's mean is np, and variance is npq. For example, x is b, 500, 0.2. Find Px less than or equal to 110. First, let's check if we can use normal distribution to approximate it. Np is 500 times 0.2. It is 100 and is greater than 5. Nq is 500 times 0.8. It is 400 and is also greater than 5. So it's good. Next, mu is Np, which is 100. Sigma square is Npq, which is 500 times 0.2 times 0.8. It is 80. Therefore, we get a normal distribution y, with mean 100 and variance 80. Now Px less than or equal to 110 is approximately Py less than or equal to 110. But is it correct? We know y is continuous, therefore Py equals 110 is 0. However, x is discrete, and Px equals 110 is not 0. Therefore, if we use this approximation, we'll lose the probability at 110. For this reason, we move 110 to 110.5, so that 110 is included. Therefore, Px less than or equal to 110 becomes Py less than 110.5. From here, we can standardize it to phi, 110.5 minus 100 over square root 80. Remember to square root 80, because 80 is the variance. This is phi 1.174. So the answer is 0.8798. The change from 110 to 110.5 is called continuity correction. We'll look at it in detail next. Continuity correction, or CC, is needed when a discrete distribution is approximated with a continuous distribution, because for continuous distribution, the probability that x exactly equals a value is 0. Remember, CC is only needed when you use normal to approximate binomial. If it's already normal, there's no need to use CC. Now let's look at all four cases. For x less than 5, 5 is not included. So we use y less than 4.5. For x less than or equal to 5, 5 is included. So we use y less than 5.5. For x greater than 5, 5 is not included. So we use y greater than 5.5. For x greater than or equal to 5, 5 is included. So we use y greater than 4.5. The key is to see whether the value is included or not. X is b, 80, 0.4. Find Px less than or equal to 34. Px greater than or equal to 26. And Px greater than 30 and less than or equal to 40. Let's see if Np and Nq are greater than 5. Np is 80 times 0.4, which is 32. It's greater than 5. Nq is 80 times 0.6, which is 48. It's greater than 5. So we're good. Mu is NP, which is 32. Sigma square is NPQ, which is 80 times 0.4 times 0.6. It is 19.2. Using continuity correction, we changed px less than or equal to 34, to py less than 34.5, because 34 is included. Standardize it, we get phi, 34.5 minus 32 over square root 19.2. Remember to use square root here, because 19.2 is the variance. This is phi 0.571. It is 0.7160. Using continuity correction, we changed px greater than or equal to 26, to py greater than 25.5, because 26 is included. Standardize it, we get pz greater than 25.5 minus 32 over square root 19.2. This is a negative number. By symmetry, greater than negative is equal to less than positive. So it becomes phi 1.483. This is 0.9310. Using continuity correction, we changed px greater than 30 and less than or equal to 40, to py greater than 30.5 and less than 40.5. Standardize it, we get phi, 40.5 minus 32 over square root 19.2, minus phi, 30.5 minus 32 over square root 19.2. This is phi 1.940 minus phi minus 0.342. Phi minus 0.342 is 1 minus phi 0.342. So the answer is 0.6076. In this class, we learned a binomial distribution B, N, P, can be approximated with a normal distribution N, NP, NPQ, if NP and NQ are both greater than 5. Continuity correction, CC, is needed and only needed in approximation. When standardizing, remember to use the square root of NPQ in the denominator.